So starting with presentation 2B. To be or not to be? Okay, about mechanical energy. We're going to focus on roller coasters. So your homework is to go on a roller coaster or snowboarding or juggling for homework. Okay, so when you are putting something up at the top of a mountain, at the top of a roller coaster, if you're throwing a ball in the air because you're juggling, okay, you are giving something potential energy. So the movement energy is called kinetic energy. That's this EK at the bottom. Okay, E is for energy, K is for kinetic. These are all energy. They're just the little letters underneath tell you what it's for. Okay, so mechanical energy, and this example has a little m, and then P is for potential energy. Okay, so at the top of this little juggling guy, it has a maximum potential energy, and then as it's moving, that's kinetic energy. Okay, so this little penguin sliding down, that's kinetic energy. Okay, this guy climbing the mountain up is acquiring potential energy. Okay, is he moving to get there? Yeah. Tobogganing is like, going down on a sled, super fun. You definitely need to do that. If this was winter time, I would say you have to go do that for homework. Right, so this is a great little graphic. Okay, it's showing your potential energy as you go up. Okay, and kinetic energy in this example is 100% the whole time, just about, because you are going fast, right? So at the very top here, not much movement, increasing movement, more kinetic energy, lots of kinetic energy, and slows back down. Okay, I'm not going to let that run again, just so you can watch what the red is doing. Maximum potential. Maximum potential. Maximum potential. Okay, now take a look at the green. Super fast. Slowing down. Super fast. Slowing down. Super fast. Okay, I might not be saying it right, but whatever. Okay, you're seeing what's going on in the chart. Okay, there you go. As kinetic energy increases, potential energy decreases. As potential energy increases, kinetic energy decreases. Okay, that's what these mean. So this ride is pretty fun. It's your energy due to your position. So on the ground, you have 0 joules of energy. So if you'll totally remember what we learned yesterday, that work is force times distance. And in this case, you need a force to lift the car against gravity, right? They need a motor to pull you up and all your friends in that little cage. And the distance the little ride goes up the tower is how much work's been done. Okay, so you're gaining potential energy by doing that. Okay, so we haven't gone through this yet, so let's do it now. Let's switch to the document camera. Okay, FG is MG. Okay, you're like, what? So let's add that to what we're doing. Okay, so in your book, page 173 has the section about gravitational potential energy. Okay, it's showing mass measured in kilograms, which we actually used before when we were doing chemistry. And then we have weight due to gravity, okay, is here. And you also have acceleration due to gravity. Okay, and you might as well just memorize it right now. It's 9.81 meters per second squared. Okay, some people tend to round it up. Sometimes you'll see it where they put 10 meters per second squared, but that's something to memorize. Okay, so let's put that on our formula sheet. Okay, and our equation sheet. So we had all our other ones. Okay, velocity, displacement, time. Okay, and then we needed a new page because we have so many lovely variables. Okay, so we had work. We had force already. Let's just put mass again to remind us, so we don't have to flip the page over. Okay, they're measured in grams or kilograms. And 1 kilogram, there's 1,000 grams. Okay, and the new one is gravity. Okay, specifically acceleration due to gravity. Okay, so how much force is going to go into that watermelon that smashes as the guys from the office drop it onto the trampoline? That's going to be a certain number based on gravity. Okay, so you're going to take the mass of the watermelon and times that by the force of gravity. Okay, so specifically, let's put 9.81 meters per second squared. Okay, and now we have a formula to go with it. So let's add that to our formula sheet, okay, which is a couple pages away. Okay, and let's put force okay, and let's pretend that you needed to rearrange that formula for some reason, because you want it to calculate mass or you want it to calculate gravity, which you probably never do because we know gravity already. But maybe we'll go to a different planet. Sometimes there's questions about going to a different planet, and you get to calculate those. Okay, so Fg equals mg is another one of our formulas that we get to work with. Aren't we lucky? Yeah, so this has an example of the moon. Okay, so if you needed to calculate the gravity from the moon, then you could. Okay, so we have a sample question here. Let's pretend your mass is 50 kilograms and gravity is 9.81. Okay, you would put that your weight, the force of gravity, right, on you is mass times gravity, so 50 times 9.81. That would be your acceleration due to gravity. Okay, and who came up with that? Newton, apparently, right, with the apple. Yeah, so homework, go on a ride at Cali Park. All right. Next, you have some examples that you can work with. Okay, and we're going to add height. So, yes, we have acceleration due to gravity, but often we're lifting something from a height. Okay, so let's add that to our formula sheet. Okay, and also our list of variables. Okay, so EP, this is potential energy. Okay, is mgh. Okay, so for any of these, it's just divided by potential energy here. Okay, if they wanted you to calculate gravity, the energy divided by mass and height. So these are times, right? You'd multiply them if you needed to. And if you needed height, it'd be potential energy divided by gravity times mass. Okay, let's put that in a box. Okay, this one you'll probably have memorized by the end of the day. Okay, and let's add our H for height to our study sheet. And that's measured in meters. Okay, so next step, let's do a practice problem. Okay, so you have one here. Okay, 3 kilogram box is lifted by an upward force of 1.50 meters, so 1.5 meters above the surface of the earth to the top of a table, like a box of textbooks, I guess. What is the potential energy stored in the box at this new position? Okay, so some people are just going to say, oh, I'm going to do that in my head. 3 times 1.5. But you also need the gravity part. Okay, you need the 9.81. So, doing the steps. Okay, let's do this person going on the ride. 25 kilograms. Okay, you take a second to try to do it on your own. Let's have a little bit of a race. Okay, I'm going to list my variables first and put what page this is on. 174, and that's number 1. Okay, start by fishing out the numbers. Okay, next step is putting in the formula. Okay, so I'll show you my work here. Okay, so we put the mass, we put the height, and we know we just learned about potential energy, so obviously this is going to need the gravity in the question. Okay, acceleration due to gravity. And then they're asking, what's the potential energy, gravitational potential energy? Okay, so we know that we need to use this new formula that we just got. And let's put our numbers in. Step 3, mass. Okay, and I'm going to put them this way, just to make it look different than our usual height. Oops, let's put them in order. Okay, we want to put mass times gravity times height. That's a good habit to put things in order so we don't forget anybody. And we're putting all our significant digits all the way. We're showing our work. And then you're looking at my sample and saying, hey, you forgot your units in the 25 kilograms. You're right, I sure did. Okay, and you're making sure that this is in kilograms and this is in meters. Because sometimes they'll give you kilometers or grams. Okay, and you need to convert that to the right units. Okay, and then you ask your calculator. You say, hello, good morning, calculator. Did you have a good sleep? Yeah, I sure did. 25 times 9.81 times 4. Okay, 981. That's interesting. Oh yeah, makes sense. 25 times 4 is 100 times that. Technically didn't need a calculator. Okay, 981 what? Joules. Okay, now let's check significant digits. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, we're good. Okay, let's put that in a box. We win. We did it right. Yay for us. Okay, sample 2. We are going to try to find height. Okay, so in this question, you have a 55 kilogram diver jumping on a diving board. Looks fun. Okay, and this is the energy that he started with. Okay, so we're wondering how high is the diving board, right? So same process, list your variables. This is your mass. That's your energy. You need to look for height and gravity. Okay, so using this formula, we have energy divided by mass times force of gravity. Okay, this and this. So we end up with 10. Okay, let's do this practice problem to prove that we can do it. Okay, and there's also elastic potential energy we'll just mention while we're here. Okay, so that's stored energy, and thank goodness we have trampolines that were invented so we can understand this a lot better. Okay, so you try that on your own. Okay, and we'll put the solution shortly.